Welcome to aminacademy.com. In material science and engineering, let us do some introduction. Please take a few moments and reflect on what your life would be like without all of the materials that exist in our modern world. Believe it or not, without these materials, we won't have automobiles, cell phones, computers, internet, aeroplane, ship, and home appliances, furniture, stylish clothes, nutritious food, refrigerators, television, computers, like etc. The list goes on continuously. That all we need. Virtually every segment of our everyday lives is influenced to one degree or another by materials. Without them, our existence would be much like that of our Stone Age ancestors. In modern age, these are the very important materials that we need day to day life. Historically, the development and advancement of scientist societies have been intimately tied to the members' ability to produce and manipulate materials to fill their needs. In fact, early civilizations have been designed by the level of their materials development, that is the Stone Age, Bronze Age, Iron Age like. Materials science has shaped the development of civilization since the dawn of mankind. Better materials for food, tools and weapons has allowed mankind to spread and conquer, and advancement in material processing like steel and aluminum production continue to impact society today. The earliest humans had access to only a very limited number of materials, those that occur naturally: stone, wood, clay, skins, and so on. With time, they discovered techniques for producing materials that had properties superior to those of the natural ones. These new materials included pottery and various metals. Furthermore, it was discovered that the properties of materials would be altered by heat treatments and by the addition of their substances and improve its durability. At this point, materials utilization was totally selection process that involved deciding from a given rather limited set of materials that one best suited for an applications by virtue of its characteristics. The development of many technologies that make our existence so comfortable has been intimately associated with the accessibility of suitable materials. And advancement in the understanding of materials type is often the forerunner to the stepwise progression of technology. For example, automobiles would not have been possible without the availability of inexpensive steel or some other comparable substitute. Material science and engineering, why we need. Sometimes it is useful to subdivide the discipline of material science and engineering into material science and material engineering subdisciplines also. Now, before that, we have to study about the material structure, some introduction. Structure is at this point, in brief, the structure of a material usually relates to the arrangements of its internal components. Structural element may be classified on this basis of size and its this regard. There are several levels. Subatomic structure. On this point of view, involves electrons within the individual atoms, their energies, and interaction with the nuclei. Next, atomic structure. It's deal with to organization of atoms to yield molecules or crystals. Nanostructure. What is nanostructure? Which deals with aggregates of atoms that form a particles, that is nanoparticles, that have nanoscale dimensions less than about 100 nanometers. Next is microstructure. Those structural elements that are subject to direct observation using some type of microscope. Structural features of having dimensions between 100 nanometer and several millimeters. That is 100 nanometer to several millimeters. These are microstructures. Next is macrostructure. Structural elements that may be viewed with the naked eye, with scale range between several millimeters to the order of meters, that is millimeters to meter sizes. Now, nano is less than 100. Nanostructure is less than 100 nanometer. Virtually all important properties of solid materials may be grouped into different categories: mechanical, electrical, thermal, magnetic, optical, and some branches. For each, there is a characteristic type of stimulus capable of provoking different responses. First is mechanical properties, which relates deformation to an applied load or force. For example, include elastic modulus, stiffness, strength, and resistance to fracture of that materials. Deals with mechanical properties. Next is electrical properties, the stimulus is an applied electric field, like typical properties include electrical conductivity and dielectric constants. It deals with electrical properties of the material. Next is thermal properties, which are related to changes in temperature or temperature gradients across a material. For example, the thermal behavior include thermal expansion and heat capacity of the material. Magnetic properties, the response of material to the application of magnetic field, that is common magnetic properties include magnetic susceptibility and magnetization, which deals with magnetic properties of the material. Next is optical properties. The stimulus is electromagnetic or light radiation, index of refraction and reflectivity are representative optical properties of the material. In addition to structure and properties, two other important components are involved in the science and engineering of materials, namely processing and performance. With regard to the relationship of these four components, the structure of material depends on how it is processed. Here, that is first here, four components, that is first processing, then it gives next structure and properties, and performance. The relationship among processing, structure, properties, and performance of material may be depicted in linear fashion and in the schematic illustration given here. Throughout this text, we draw attention to the relationship among those four components in terms of design, production, and utilization of materials. Why we should study material science and engineering? Why do engineers and scientists study materials? Simply because things the engineers design are made of materials. The engineering design all are made of materials. Many and applied scientists are engineers. For example, mechanical, civil, chemical, electrical engineers is at one time or another exposed to a design problem involving materials. For example, transmission gear, the superstructure for a building, an oil refinery components, or an integrated circuit chip. These are the some needs from the engineers to develop. Of course, material scientists and engineers are specialists who are totally involved in the investigation and design of materials. Many times, an engineer has the option of selection of best material from the thousands of materials available. The final decision is normally based on several criteria. First, the in-service condition must be characterized. For this dictate the properties required of the material. Only on rare occasions does a material possess the optimum or ideal combination of properties. Thus, it may be necessary to trade and characteristics for another. The second selection consideration is any deterioration of material properties that may occur during service operation. For example, significant reductions in mechanical strength may result from exposure to elevated temperatures or corrosive environment and it deals the failure. Finally, probability, the overriding consideration is that of economics. That means cost conditions. What will be the financial product cost? A material may be found that has been optimum set of properties but is more expensive. For that, here again some compromise is inimitable. The cost of a finished piece also includes any expensive incurred during the fabrication to produce the desired shape. The more familiar an engineer or scientist is that with the various characteristics and structure property relationship as well as the processing techniques of materials, the more proficient and confident he or she will be in making best material choice based on these criteria. These are, we discussed some introduction about material science and engineering. In more details, we'll discuss in further videos. We have done. Please subscribe our YouTube channel.